Alright, so for our AP Physics project, what we decided to do as a group in our table of four is we decided to analyze the physics in video games. We decided to mainly put our focus towards gravity because that's something consistent and easy to test throughout all the games, and we wanted to compare them all and see which one has got the closest representation to real life. So each of us took control of analyzing one video game, and so this is what we got. So the first game analysis is done by Billy, and he's taking a look at the gravity in GTA. Flawless.
To test the gravity in GTA, I decided to fly up to the tallest building in the game and fling my character off of it.
Son of a...
The height of Maze Bank Tower is approximately 316 meters, and it takes 5.35 seconds to impact the bed of the truck.
Nice.
Plugging this time into the kinematic equation gives an acceleration due to gravity of approximately 22 meters per second squared. Also, the force of gravity of my character wildly fluctuates based on his stance while he is falling. The game severely overestimates air resistance, as a horizontal body position takes twice as much time to reach the ground as a vertical body position.
The next game physics analysis was done by David, and he's going to be analyzing the gravity in Batman Arkham Knight.
So I'm playing Batman Arkham Knight. I climbed up on top of this 118-meter building, trying to find the force of gravity first. Jump off, and it takes me 2.13 seconds to reach 10 meters, and we'll use that to help me calculate force of gravity. Alright, so I fell 110 meters. It took 2.486 seconds. Doing some math, I got a acceleration due to gravity of 35.59 meters per second squared.
God tier. So Ryan decided to look into Minecraft, see what he could find for Minecraft physics.
We are playing Minecraft with the boys. We are testing the gravity to see how it compares to gravity in real life. To start off, 1 block in Minecraft is equal to 1 meter in real life. We made 4 different towers, which are 5, 10, 15, and 20 meters tall. We then timed how long it would take to hit the ground from the top of each. Using the same kinematic equation as before, we got an average of about 30 meters per second as our gravity constant for Minecraft, which is 3 times more than in real life.
And for my game, I picked Far Cry 5, and I decided to analyze the gravity of this. Now, for all of these games, you need a reliable height in order to get your distance traveled for the equation. So I decided to use the character's grappling hook rope, which maximum stretch distance, I stretched out horizontally, and it appears to be 30 meters. So, knowing the rope is 30 meters long, I found a cliff that was the same height as the maximum stretch distance of the rope. I then jumped off of it and timed how long it took to reach the bottom. Alright, here we go. Since I went 30 meters in 1.7 seconds, using the equation distance equals 1/2 at squared, I calculated the acceleration due to gravity to be 19.2 meters per second squared. To conclude, every game exaggerates the acceleration due to gravity. The closest to real life we tested was Far Cry, and that still has gravity 2 times as strong as it is in real life. Unsatisfied with these results, I decided to test one last game. The last game I decided to test is called Dying Light, which is a parkour game, and I figured if you're going to make a game dedicated to parkour, you're at least going to have the gravity more accurate than some of these other games where gravity's not really the main focus. Once again, I used a grappling hook rope to get a standardized distance. In Dying Light, this distance is 25 meters. So, I looked up a tower to this maximum length and dropped off of it. So, it took me 1.852 seconds to close that distance of 25 meters, and using the same old equation, that gets you a little g of 14.57 meters per second squared. This means that even in games where the core gameplay relies on gravity, the acceleration due to gravity is exaggerated. We also analyzed a couple of other random game physics things. Here's David explaining the force on Batman when he uses his parachute cape 10 meters off of the ground.
So once Batman is 10 meters off of the ground, he deploys his cape as a parachute to slow his fall. However, this slows his fall down to the point that his spine could sever. Here's the math. Alright, so this is going to take some explaining. His initial velocity right before he slows down is 88.48 meters per second, calculated by multiplying acceleration in time. Then he reaches the ground at 0.784 seconds after he deploys his cape. That means he goes from 88 meters per second to 0 in less than a second. Calculating the force, F equals ma, you get a whopping 9,738 newtons of force, well above the force needed to sever a person's spine, which means he's not looking for Rachel anytime soon.
Rip Rachel. So I analyzed the force on the player's hand when they use a grappling hook and dying light, and because they go from a velocity of 0, standing still, to instantly jerked forward by the grappling hook, and I found out how much force is on his arm. So he travels 25 meters in 1.7 seconds, meaning he travels with a velocity of 14.1 meters per second. So he goes from completely still into this velocity in about 0.3 seconds. So if you divide by the change in velocity by the time, you get an acceleration of 47 meters per second squared. So we know F equals ma, so assuming he weighs 65 kilograms, multiply that by his acceleration of 47 meters per second squared, and he's got 3,000 newtons of force applied to his right hand. So that's who knows what that would look like after this would happen in real life. Yes! Amazing.
Projectile motion, baby.
I climbed up on top of this 118-meter building, looking for Rachel.
Where's Rachel? Ah!
Where's the spot I can get this boy through? Here we go.
I'm just over here now.
Oh, did you throw yourself? Oh, nice. Yep.
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 I was able to come up with a force of gravity of 35.59 meters per second. Oh my!
Acceleration due to gravity. I gotta work with this, people. This is bullshit.
That's only reading the
I'm saving that. Dude, oh my god. Oh my god. Tree! What? What? How are we okay?
At 10 meters, it took me 2.13 seconds.
Garbage, David. Yeah, garbage. You're terrible.
That was pretty bad, David.
You should be ashamed of yourself. Why haven't your parents disowned you? Doing. What? What did I just witness?
Actually, kind of hungry. Anyway, so what?
What?
Damn it!
What is happening right now?
Whoa! What the hell?
What? You just pulled. How did you do that? Are you still in it? Alright. I nailed it.
What's up, Jake Paul? Welcome to the Jake Paul vlog. Remember, Domino's haters every day. Buy that new merch. Link in the description below.